Welcome to the AI Research Roundup. I am your host, Alex. Today is May 12th, 2025. We're looking at an ICLR conference paper, The Hidden Cost of Waiting for Accurate Predictions, published January 22nd, a little over 3.5 months ago. This paper tackles a key challenge in AI for resource allocation. Is it always better to wait for more accurate predictions? The authors explore this trade-off, considering that delaying intervention means some individuals might suffer negative outcomes or effectively fail out of the population. They show that surprisingly, overall ranking quality for allocating resources can decrease, even if individual predictions improve. Alright, so the authors illustrate this with Figure 1, which shows results from semi-synthetic experiments. We're looking at 3 bars charts, each representing a different relative budget size. That's the total budget, B, divided by the population, N. As this budget per individual goes from 5% up to 20%, you can see the blue bars, representing the percentage of budget spent, become much more concentrated at the very first time step, T equals 1. The orange line, Q of T, depicts an optimal decision threshold, which stabilizes early on. This really highlights how larger budgets push the optimal strategy towards earlier intervention. Building on that, Figure 2 explores optimal overtime allocation for different initial conditions. We see 3 scenarios, each with a different starting assumption or prior about the population's failure probabilities. These are shown as initial distribution graphs at the top. As this prior shifts from many individuals being initially high risk in panel A to fewer in panel circa. The blue bars, showing budget spending, spread out more. The orange line, an optimal decision threshold, also adjusts. This underscores how higher initial inequality, where more individuals are at immediate risk, pushes for very early, concentrated intervention, even with a fixed budget. Okay, to help us follow their mathematical framework and the concepts we've been discussing, the authors provide Table 1, which is a glossary of key terms. For instance, they define P as an individual's failure probability. That's the chance they'll experience a negative outcome. AT represents the active population, so those still in the running for intervention at any given time. T. They also clarify terms like expected utility, which is the benefit the planner aims to maximize, and ranking loss, a measure of how well individuals are prioritized. This glossary is quite helpful for navigating their technical arguments. So, moving on from the definitions, Figure 3 visually illustrates the effect of budget and inequality on one-time allocation. On the y-axis, we have delta WT, that's the change in expected utility if we delay allocation by 1 step. A positive value means delaying is good. The x-axis shows the relative budget. The different colored lines correspond to different levels of G, a parameter reflecting inequality, specifically related to what the authors term a G-decaying distribution property of failure probabilities. Essentially, a lower G signifies higher inequality. We see that with higher inequality, so the green lines for low G, delaying allocation quickly becomes detrimental, especially as the budget grows. So, to bring this all together, the core insight from this work is that simply waiting for more accurate predictions isn't always the optimal path for societal resource allocation. When we're dealing with dynamic populations, where individuals might experience negative outcomes and thus leave the active group needing help, and especially when there's significant inequality in their initial failure probabilities, intervening earlier, even with less certain data, can actually lead to greater overall social welfare or expected utility. It's a powerful challenge to conventional wisdom. Thanks for tuning in to AI Research Roundup. I am Alex.